You decide to hide out on the roof of the school until the teachers arrive in the morning to throw water balloons at them. You throw the balloons with a velocity of 15 meters per second at 35 degrees below the horizontal. If the roof is 12 meters high, how far from the edge of the building will your balloons hit? We have our drawing done up here on the board. Here's our 12-meter tall building. You're on top of it. You're going to throw the ball, or the balloons, with a velocity of 15 meters per second. So that's the hypotenuse of that triangle. The velocity in the x is the adjacent side. Velocity in the y is the opposite side. And 35 degrees is in the top left corner of the triangle that we have drawn. As I said, the building is 12 meters high, so our displacement is going to be down 12 meters. And we're looking for how far away the balloons are going to hit the ground. So that would be the displacement in the x direction. Pulling our numbers out of our picture and plugging them into our x and y columns. In the x direction, D is the question mark. We don't know the velocity in the x yet, but we'll solve for that one in just a moment when we do our right triangle geometry. In the y direction, displacement is negative 12 meters, acceleration negative 9.8 meters per second squared, and V naught we don't have yet, but we'll solve that in just a second, again when we do our right triangle geometry. So for our right triangle, velocity in the x direction, being the adjacent side, is going to be found by using cosine. So velocity in the x equals the cosine of my angle, which is 35 degrees, multiplied by the velocity that you throw the balloons with, which is 15 meters per second. When I plug that into my calculator, I would get a velocity of 12.3 meters per second for the velocity in the x direction. In the y direction, it's the same process, but because it's the opposite side, we're going to use sine instead of cosine. So the initial velocity in the y direction is the sine of 35 degrees multiplied by 15 meters per second. When I plug that into my calculator, I get 8.6 meters per second for the initial velocity in the y direction. We'll plug those numbers here into our columns. So velocity in the x, 12.3 meters per second, and velocity in the y is 8.6, but don't forget, it's 8.6 down. Because it's 8.6 down, it's actually negative 8.6 meters per second. We have to have the negative, otherwise that's the difference between throwing it up and out versus down. And we get a very, very different answer on how far the thing is going to go if we throw it up and out as opposed to down toward the ground. We're trying to solve for the displacement in the x direction. We do not have enough information, as usual. If we have time, we'd be good to go. If you're not sure what I mean by that, we only have one equation in the x direction, which is displacement equals velocity multiplied by time. We know the velocity is 12.3, so if we have time, we're able to solve very, very easily, multiply those two numbers together, and we're done. So we're going to solve for time in the y direction and use it in the x direction to get the thing that we actually want. So in the y direction, we're going to use the equation without vf in it. That would be d equals v naught t plus 1/2 a t squared. D is not 0 and V naught is not 0, so nothing cancels out. So we're going to have to do the quadratic formula for this equation to solve for time. That looks like time equals negative velocity plus or minus the square root of the initial velocity squared plus 2 acceleration displacements divided by the acceleration. We can now plug in our numbers and solve. So time is going to equal negative. Notice that's already a negative. So negative 8.6 becomes a positive 8.6 meters per second plus or minus the square root of negative 8.6 meters per second, and that gets squared. Remember, a negative number times a negative number. So negative 8.6 times a negative 8.6 will become a positive. So negative 8.6 squared will be a positive number. Plus 2 times negative 9.8 meters per second squared times the displacement, which is negative 12 meters. And all of that is going to be divided by negative 9.8 meters per second squared. When I plug that into my calculator, I'm going to get two possible answers. I'm going to get a negative and I'm going to get a positive. The positive number that comes out is time equals 0.92 seconds, or in this case, I would get a negative, and that would be negative 2.7 seconds. Now, we never deal in negative time because negative time is traveling back in time. That's not possible, so we're not going to worry about the negative time. Negative time is going to be ignored in this problem, and instead we're going to use the positive time of 0.92 seconds. So we can finish this up very easily. Displacement in the x direction is still equal to velocity multiplied by time. It's the velocity in the x direction, which is 12.3 meters per second, multiplied by the time we just found, 0.92. And we plugged it into our calculators, we get 11.3 meters for how far the balloons are going to go before they hit the ground.